All right, let's just start it. Okay, sorry about this IBM logo here because I was not able to find my the source file, LaTeX file to kind of edit it. So it's an old one actually, almost a year back. I had kind of given somewhere some training within IBM itself when I was working with IBM. So so pretty much I will kind of try to kind of cover it here. What I'm going to introduce here is Python as a programming languages and how to set up the environment and what are the learning path. And then we will jump directly to Jupyter Notebook, where we will be doing some see hands-on how the Python programming languages is. And then I will quickly go to the next session, which is implementing a machine learning model, maybe logistic regression or sort of, maybe it is easier and to implement faster. So which I have done, and I will share with you. So well, this is pretty much is kind of taken from different sources from it, and that's why it has been attributed here. So a little bit of history, because that's always kind of give you interest why this all started. So a lot of information on this first slide here, but this is the guy, Guido von Rossum. He was working at CWI, that is Center of Wiskunde and Informatics. So translating in English, it is kind of NASA Research Center for Applied Mathematics and Computer Science in Amsterdam. And while he was a webmaster, that time webmaster and system admin used to be the main job in 90s, you know. But he was kind of working on a project and helping other researchers, and he come up with a certain functionality he wanted to automate, and he didn't find a better language to do that. And Perl was there and some other TK and all, but that's how kind of he come up with this language. And the language he kind of gave the name Python, not on this name, which is Python, the creator, but Monty Python, which is kind of, in fact, I have not watched. Of course, after that, I got to watch it on YouTube. What was that? It's a kind of a BBC 4. It was a kind of a sitcom, perhaps. And okay, so I will kind of quickly go what are the different kinds of programming languages are. So then traditionally there is a kind of two kinds of programming languages. One is where traditional programming languages, which you kind of use for kind of creating, and something is called a scripting. And a scripting language like a script, like a Perl it comes into that, and where you don't need to kind of compile it each time. Pretty much on the command prompt, you can kind of write, assign variables and set it, and very next time you can use it. It does memory allocations and everything indeed in backend. While C++, you need to write the code, then kind of compile it. It converts into bytecode. It will allocate whatever the variables, and it has allocated memory. Then your assignment is done. Whatever the computation you are doing in the logic, that will execute it. So it is very beautiful in the scripting, in the sense kind of on the command prompt you are doing it and everything. So you don't need to kind of go back and kind of recompile. Someone who has worked in C, C++, and or even for Java and all, so you know that it is sometimes painful, because you need to keep toggling between them until you are using IDE or some integrated development environment, or to say. Okay, so but it has got a programming language has got its own advantages, because you can kind of monolithic applications you can create standalone, but scripting is like it will do some small task, right, for automations and all. But over a period of time, Python has got picked up by a lot of in scientific community. So they developed a lot of libraries independently. And it has pretty much replaced numerical recipes in C. Used to be those who used to high performance computing. Myself is, that's why I'm citing this example. So like NumPy, SciPy, and all these libraries are pretty much available. Even you can create graphic user interface, and now the web applications also you can create using Django, and different Flask and different kind of frameworks is available. So Python has evolved not only scripting, I will say it is in between. But if you're going by the rigid definition, it is a scripting or is a compiled. So certainly it is a scripting. Okay, but now it is coming in between somewhere. All right, so let's move on to here. So Python 1, then kind of 2 became very strong, and it has come with a support. And then Python 3 came. Now the Python 2 starting of this year has been kind of stopped its support. So officially now Python 3.3 is perhaps is in the market. No, 3.8 perhaps is in the market. And that's how it is. But even though certain applications are there in Python 2 has been developed in kind of not exactly legacy, we can say, but let's loosely use the legacy codes are there. So there is a kind of functionality. If you look at in the Python installations, which Python, and they will look, and you will find there will be always one library called 223. So it kind of give you kind of back compatibility, also forward compatibility of that sort. So even though, don't worry, if you have Python 2, it will work. But whatever you are going to work now, it makes sense that you should use Python 3. And only challenge is that it is very like indentation matters in this. So if you are familiar with the any programming language, you will understand if you have the curly braces and all, whatever you write, it is fine. But Python is very strict in the how you do the indentation. So your code will kind of won't work if there is a kind of a simple one space here and there. So you need to be very careful about it. So for that, it is not advisable that you should be working on any sort of simple text, though I prefer to write Sublime text on that sort of text editor. But there are beautiful text integrated environment, and like a PyCharm and so on and so forth is available. So let's look at quickly how you're going to set this. So you go to python.org. And you can download it, or whatever the version. So Python 2, if you kind of after installation, if you just type Python 2 or just Python, this is something like it will come. And since I think it is kind of coming that, okay, it won't be supported. Now let's say you have Python 3. This is how it is going to be. And C languages support, and these are something which we are not going into the details. What are the things? Pretty much you can look at. And but let's say we are where we are going to focus. Since we are looking from the machine learning data science perspective, our focus is going to be SciPy, Pandas, and IPython. So there we will head start directly. Okay, there are a lot of kind of web development: Django, Pyramid, Bottle, Tornado, Flask, Web2Py, so many. Graphic user interface, of course, you can kind of create a PyQt, like a TCL TK and Qt is kind of, which is, in fact, I don't know all of them. I'm a little bit familiar with the PyQt and all. Yes, software development, of course, there is a lot of is being used, and also like a system admin and automations and all is a lot of kind of Ansible, Salt, and OpenStack that pretty much is using, which is in Python, it supports. All right, let's head to installation. So if you're using Windows machine, this is how, while you are installing, it will look like. I would suggest you can select yourself. This is how you can select yourself where you want to install. Otherwise, by default, it will go somewhere, see user, and you can go by that by default settings as well, kind of. And but this one, if you choose, you don't need to kind of set it up where you kind of open your Python command. You don't need to kind of set it up environment variable, though I will tell you how to set it up, so that from any command prompt, if you open it, or terminal you open it, automatically Python libraries will be imported. Otherwise, you need to kind of always include that in your path. So it is advisable that you include that. So automatically path environment variables will be set up for you. Easy. All right. So let's check it with how you have kind of installed. So this is Python package installer. So this is very important. Whatever the packages you need is just one command, you can install whatever it is. So this is where PIP is nothing but the Python installer package. So it lies in between in your core Python installer with the library within that, if you go. But if you have included your Python variable, the path where it is installed, PIP and install whatever, or upgrade. And there are a lot of kind of things like Python upgrade -u, Uh, so these are kind of arguments when you are kind of on command line, you are giving. Well, I will tell you how it is. Like you will see here Python minus C. So it is kind of, I'm giving a command line argument. So Python is executing and command line argument, and then I'm giving that, okay, what it has to do within that. So even though I'm not going into the Python environment, but kind of I'm in, essentially what it does, that it will temporarily open a Python. I will execute this and come back to the prompt. Okay, so this is where it is. If you just a quick check, if you are kind of whether you have installed, if you do this, so let's say math library, which is the default, it is part of echo dollar this, it will show you that 0 means successfully installed, and if through some that of error, it means it is not installed. So so you need to kind of install those packages. You can pretty much go pip install numpy. Math is of course by default it is installed, I think. So even though if you import this, it will execute. But say NumPy is not installed. So what I'm going to do, how to install? Look at here, pip install NumPy, and after that, whatever the dependencies are, all it will install. There are certain other arguments we can pass as well, like by force and other things, which you will learn it if you kind of facing some challenges. But simply this is how, when you are kind of starting off. So let's go to the next slide. And okay, so okay, now we come to that.
Hemant, sorry,
yeah, sure.
Don't mean to interrupt. Is it okay to ask questions as you go, or do you want me to save them for later?
Yeah, you can ask. Yeah, let's go with this so far what we have done. Yep.
Okay. So part of the course, there will be Python basics, another instructor covering, the environment setup or whatnot.
Okay.
Right. So part of the data science program, we want to focus on real world use case solving. Right.
All right.
So, hey, let's say, marketing team is trying to solve for, multi-touch, attribution, right? How do you, solve for that? How do you, identify the right data science methodology to solve for that, right? And if you want to build, a campaign recommendation, right? What engine, what library, what package, how do you validate those type of things? Are you going to cover those as well? Part of the next?
Okay, so well, those are the things I'm not going to cover in the detail, because so I will kind of so, but certainly for machine learning, one simple logistic regression or linear regression, a logistic regression, let's say for classification, I will take an example. That's and what are the things is required. So okay, so I thought, okay, when we're starting, what kind of we need to set the stage and give the background, like why this particular language we are using it. So let's say I thought, okay, Python is that we decided why we're going with Python, and what is required. Yep.
Yes. The only reason is, we're prepping the students for the real world, right?
Right.
In real world, for the most part, there is IT department who helps, with the logistics.
Correct.
Right. Okay. And pretty much, the moment they come in, they can call the help desk, and they will get that thing installed for them.
All right.
Right.
Okay.
In most cases, especially in this day and age, we don't need to necessarily go into the details of installation, if you will, right? But rather, will you be able to prepare a document like, hey, this is here is the pre-course prerequisite. Install, here is step by step guidance for you to install and come prepared to the course.
Right. So pretty much actually that should be part of like so let's say Python it's covered, which is kind of so so this is where kind of data visualization, what are the libraries is required, what are the things, so that should be covered. So like I say, it's kind of impromptu. I have not prepared for anything for this one. So what I'm going to do, let's go directly to the machine learning part. Okay.
Yes. Yeah.
All right.
Let's jump.
Yeah. All right. So just a minute. So I hope you're. Yep. All right. Okay.
I love how you navigate, Mac, with command.
Yeah. Okay, so this is a last month. I had given a boot camp, 7 days boot camp actually.
Okay.
So I will take the liberty of taking that what I had kind of covered partly.
Sure.
So bear with me for that. Of course, apologies that I didn't prepare very specific for this session.
No worries.
Yeah. So yeah.
But you mentioned only classification and clustering.
Yeah. So
Do you have
we can
expertise
cover.
in other areas as well?
Yeah, so pretty much is kind of yeah, so classification. When you kind of hear starting is a very simple one, like you were kind of giving like uh, introducing to like what are the classification, what is clustering, why there is a difference, which one
Right.
will is supervised, which is unsupervised, and when it is kind of semi-supervised or to say
Right.
kind of a hybrid model or semi-supervised or that sort of thing, where it is used, why. So let's say we are having a data where pretty much is some classes are available and we want to predict based on that, we want to train. That is a supervised, right?
Right.
When we don't know what we want, what kind of classes. So classes is like something we want to predict, so we want to infer, and but we don't have that label. So in that case, what you want is kind of use some clustering techniques. So cluster is like grouping it, right? Identify pattern in itself. So majority of the problems are kind of in comes into those where data is not enriched, it has not been labeled. Then it comes into unsupervised techniques. And then can be hybrid approach. You kind of look at, you do some ensemble methods, you train it, then eyeball it, and kind of enrich the data, and then kind of do multiple ways to enrich the data. Then you kind of start with the unsupervised to slowly go to supervised learning. So today we were going to cover supervised learning. Let's go here. All right, so the basics of this, okay. What we're gonna do is like a German credit data, which is available from here. Look at UCI. This is kind of one of the big repository. So it is from data actually. So I'm not using any live project data or something. For the sake of, certainly we can kind of look at even from Kaggle and all, which is kind of certain project, we can pretty much take it. And then we can customize for that. But so this is the data, which is kind of which is, and I've taken it and all the transformation I have done, and then we are kind of going it. So let's say this is the data which is kind of lying in my library here. Okay. Yeah, so here, if you look at here, data. Yeah, so this is the data here. Okay, so this is the data. All right. Okay, so this is the it looks like. So where all these the first line is all the parameters, right? And these are the values, okay, associated, something like 1,000 data points, okay. So we can see, we will see that here. So what I'm going to do is here, like I assume that I have installed in pandas library. Otherwise, what I will do here, I will pip install, and I will put this check here. So if I do this, it means if it is not installed, then install this. So pip install panda. Okay, let's execute it. Okay, requirement already satisfied. If it is not, I don't do that, it will otherwise reinstall or something like that. Okay, so let's say this is done. So now I will import it, this library, and let's import it and save this import as a PD. You can save it with any name. So as essentially we are in kind of creating an instance of that. So that okay, And then we will be using this. So since,
just for context, what data set and what problem are you trying to solve with this data?
Oh, okay, yes, certainly. Okay, so
Okay.
kind of, yeah. So so this is the problem actually. A problem is German is called German credit data. Okay, the German credit data is available. It was a bank which has kind of given the data and is freely available, and the data has got 61 variables, 61 parameters. And this was the data which was kind of University of Hamburg, and where this professor has kind of aggregated this data, sourced it. So we attribute to him. And this is the data set actually, pretty much, if you look at. So what it has got, the German credit data is like who are the good customer and who are the bad customer. So pretty much like the credit ratings is available in perhaps, or in US, I'm not sure, but in UK, Experian is the credit rating agency. And I'm sure like a lot of, I know a lot of my friends who went to US and they don't have credit history, and they were not getting kind of credit card and something. Relatively, it is in US, it's very kind of tough. What they actually look at, this is what they look at. They look at the credit history. But if you don't have, even though what I'm going to do is I'm going to create, I'm going to create a model based on that, those customers whose a certain bank has given the data and what their attributes was, like their demographic information, like education, whether they're employed, maybe sometimes ethnicity, whether this makes sense or not, we don't know. We will check it whether data is, but these are, and whether they are kind of expat, or they are kind of native German, what kind of job they are into, what their education level is, whether they have movable or immovable property, all sort of things, right? So these are called demographic data, and then so these are all these almost 61 types of variables. So 18 variables are there, but when we kind of translate, convert it, what I have got is like, so see, there are categorical variables. Categorical variables is like category, but we can't do mathematics on it. You know, something is said, okay, it's a good customer, and can we add 2 good customer to get double good customer? No, these are categories, we cannot. So if you are doing some imputations or computations, we need to convert it to some numeric data. Okay, so that where we kind of convert it. So let's say good customer, we label it as 1, and bad customer 2. That's how in the data. But for the sake of convenience, what we have done, good customer 0, bad customer 1. Even that is also is okay. That we can do. And so that is what I have done it here. All right.
Sorry to interrupt. I just quickly wanted to tell you that we have about 10 minutes left.
Okay.
So now in the meeting.
All right. Okay.
It's going to be ended automatically.
I see. Okay. No problem. Okay. So what I'm going to do, I will quickly run through within that. And okay. And in fact, I have a meeting at 10 as well, 11:30. Yeah. So, okay, but we can correct it if you like, kind of, I think the free version, which is kind of, we need to kind of, let me know if in that case. Anyway, so this is where data, I need to ingest it so that I can do some computations for that. So let's say I have got.
No, you can skip this part. Sorry, you can skip it.
All right, okay. So, but usually what happens that we need to kind of understand the data, do the exploratory part, understand what it is. That is called exploratory part. Once you understand each variables, how they're distributed, how their everything is, and then you kind of identify and then you go for the making a model. So this is what we are kind of looking at. So this is the data look like. Okay. And
so let's get to the good part.
All right. So, okay. So here is, okay. I need to kind of jump here. So let's say whatever I have cleaned the data and everything we have looked at, what is, we are using a logistic regression model. So logistic regression is like a sigmoid curve, S curve. So S curve is like all the data points are here at 0 and 1. Okay. So 0 is, let's say, bad, and 1 is the good customer. So if you can put it, the 2 groups, we can put it pretty much. There will be some, because when we compute intermediate values come. So we have to kind of use some kind of threshold, 0.5 and above, let's put them 1, or 0.6 and 5 above, or what, 0.7 and above, and then rest all to kind of G. So this is what we have done. And we import, we are going to use scikit-learn here, which is, so I import here scikit-learn linear model and import logistic regression within this module, and then kind of created a logistic regression model. And this is where kind of I had given a parameter for it is kind of hyperparameter value, okay, because it is kind of trying to, and here train and train value, and then like a training okay, so there is one more thing. When we are making model, we need to divide the data into kind of training set. So the training, and on the same data set, part of the data we reserve it usually 20% leftover, 30% leftover, whatever. Based on that, let's say we have enough data, then we test it. So the train is what I have labeled it, the train part and test part separately. Okay, and I randomly selected it is here. This is how I have kind of split the data. So I created the data, and then I looked at 1,000 data points were there, sorry, 800 was taken, 80% of the data on the test. And on the test, what I found it, 0, which is kind of a good customer, 610, and 1 was 190 was a bad customer. Let's check it actually, since the data has got actual, this is a predicted one, but let's say, so actually it is coming that 496 I predicted to be the correct one. Okay, so this is a confusion matrix actually. When we look at whether they are the actual good customer, I also predicted to be good customer, but there are sort of bad customer, but I predicted a good customer. That is my wrong. And then other is a bad customer, but I predicted also bad customer. That is also good prediction because I correctly identified. But there was a good customer, but I predicted a bad customer. And and also the customer is bad, but I predicted is good. So those are the wrong ones. So these are the wrong ones actually, 62 and 114. Okay, but if you look at how this kind of on the validation set, this is how it looks like, the same confusion matrix. And if we plot it, we look at here pretty much. This is how it is.
So what was the accuracy rate?
So okay, so the accuracy rate is here 65% to 70%. Okay, see here. Okay, so accuracy is 75%. So essentially what I'm going to say,
So what about the confidence level?
Okay, so the confidence level is pretty much is kind of, so here, so when we are looking at the precision and recall, so here is precision is 0.57 and recall is 0.53. So 53%, you can say that, okay, so precision is 57%.
I see.
Okay, and so this is how it is. And okay, so then KNN and all models are here. So I will kind of pause it here for then this is unsupervised techniques here. KNN nearest neighbor. We want to group them into kind of whether bad customer or good customer without looking at So that is the kind of unsupervised technique here. Okay, but here is that, okay, I need to kind of give how many cluster I want, but I know that, okay, there are two kind of group already. So it is EG, and that is what I can give K to 2 and that kind of start. But there is, when there is not known, also we can start, and there is kind of a lot of techniques to do that. When we optimally identify that what is the best way to split that number, optimal number of when looking at a certain curve, mathematical curve. So in the interest of time, I will just kind of put it here. If there is anything else, we can. And
actually, a couple questions. So who do you usually tailor these, content to?
All right. So this content was given to some graduating students who are in their final year.
Okay.
So this was, and earlier kind of I had given to IBM Guadalajara team, which we set up in Mexico, and we were to train them. So earlier, which I since there are certain parts which I cannot share, so only the presentation part, which is on Git, it is available freely. That's what I was kind of starting, or per Python program part only here. So and this.
Sounds good. John, any questions from your side?
No. It's pretty much lots of technical. So, obviously I'm not, I lost it somewhere. So yeah, we're going to discuss with our team. And if you could please send the recordings afterwards, to my email.
Sure.
Or I don't know, however you prefer.
Okay,
that'll be great. I mean, I don't have, in terms of, I already talked about whatever part I had before this session. So this session was mainly to sort of evaluate your knowledge about Python and machine learning, and just a bit, 40 minutes is not enough, of course, but yeah.
I know. Yeah, I was kind of cruising all the way. So then.
Yeah. Cool.
No, it's
Yeah, I
been
just wanted to
really-
be. Yeah, go ahead, Alex.
No, it's been great, to meet you, Hemant. Definitely,
pleasure,
shows very diligent in terms of, the details, and just want to make sure, it also, aligns, with the course and the, objective that we want to set, with the students. So we'll definitely, connect back, with another member who couldn't join as well. We'll share, the recording, and then John will be in touch with you.
All right. Okay. Sounds good.
All right,
Awesome.
Hemant, thank you so much for your time and all the efforts. I'll talk to you soon again.
Sure.
Take care.
Bye.
Okay, bye-bye.